Okay, so I'll just give a, a brief introduction to who we are. We're a 2.5-year-old company. We are making asset management software for utilities. Kalle, the CEO, and myself met in Danish Energy. Jan was my former boss. Today, we work for a broad section of typically utilities, but we also have a very interesting project with the Danish Energy Agency at the moment. We've also worked for Baner Denmark, who operate the railway here in Denmark, and they actually have a lot of issues to do with electrification. They're battling a lot of the same issues. Their peak load is expected to increase by 7 times over the next 10 years as their trains become electric. So what do we do? Well, our product Asset Life is a dashboard. Then we've got 5 APIs that you can ping and get results back. And we have a mobile app for Android and iOS. And basically, it gives CTOs at utilities superpowers. They can make 20-year investment and maintenance plans, which before was something just they could show and show to their board members and also plan with. But now actually it's becoming regulation, which is really good news for us. All 2,500 European electric utilities have to make network development plans every other year. So there's really a need to make some solid investment plans that bring down costs in spite of increasing costs because of the increasing demands due to electrification of transport and heating. And then the app is used to log a lot of data maintenance and also collect data. Collecting data is really key when you're trying to make the right decision. And our what's unique about our asset management platform is it builds upon future loading scenarios. So we take in inputs, political targets for electric vehicles, heat pumps, and solar, and see what impact that has on a grid. So, and from that, we can actually say something about the optimal placement and sizing of assets, like electric vehicle chargers. And then also another key part of this is lifetime estimates of these assets. These are really expensive things that can last 50, 60, 70 years. So it's really about making the right decision now, because we're going to be living with it for a long time. The green transition doesn't start in 10 years' time. It actually started 10 years ago. Everything we were putting in the ground has to last through the next the coming wave of electric vehicles. One of the things I thought I'd talk about today is our experience with electric vehicle charging. One of the things that our software does is it links to Denmark Statistik, the national statistics database. It also links to behaviour, which has a lot of information about buildings. We link it to Statistik, which has all the car importer data, so we can see how many electric vehicles are being sold every week. So it's collecting all of these data, but when we speak with countries around us, companies in Southern Europe, for example, they don't have this wealth of fantastic public data. Because we believe it's very difficult to have a software company that will only survive in Denmark, and we're looking abroad, we've started looking for more general ways to understand how EVs will impact the future. And one of those is looking at orthophoto data, which is overhead imagery. It's very high resolution. It's available in all countries. And we can run machine learning on it to identify where cars are parked, where they're in motion, and then also understand what that means when half of them or all of them are electric, and how it will load our infrastructure. What we get is some really interesting heat maps. We've got heat maps like this for EVs, solar, and heat pump. And then we can see in which areas there are going to be problems, which areas we need to upgrade the infrastructure, and in which areas we need to activate flexibility. So that means shift consumption or production in time, so it's out of the peak hours, as Jørn was saying, into the nighttime, for example. So here at the highest density, typically in, of course, most populated areas, you can get up to 1,000 electric vehicles in 2030 per square kilometer. And I think that, so where I live on Amager, there's an underground car park with 500 cars underneath. And it could typically be somewhere like that where half are electric. One of the really interesting things that comes out when you combine all this amazing data is you start to see some interesting correlations between EV ownership and income. That's what we've got on the left here. We also have EV ownership, house size, and on the right here we have EV ownership, income adjusted, and then which parties people vote for. So on the left here, if I should just try and explain that, on the on the x-axis we've got disposable income, and the most affluent area in Denmark is Klampenborg on the east coast of Sjælland. There, so far, around 4% of cars are electric. Down in one of the poorest parts of the country, Odense Nordøst, it's almost zero. So there's quite a strong correlation between income and EV ownership. And that also means that there's quite a strong correlation between where the first electric vehicle chargers are needed. There's all sorts of moral implications of this, which we haven't thought about so much, but it's definitely an interesting area. And then when we adjust for income, we can see it's typically the left of center parties that explains EV ownership more. So there, if you, once we adjust for income, if you vote for Alternative or Enhedslisten, we can see that you're almost 40% more likely than the average voter to own an electric vehicle today in 2020. On the other hand, if you vote for Venstre, then you are 35% less likely to own an electric vehicle today than the average voter. Of course, there are a lot more voters of Venstre, and it's very easy to get into some discussions with them about how they don't really like these results, but this is what the data seems to show us. Okay, so I'm hoping, it's always a little bit dangerous to do a live demo, but let's see. Have I still got you with me?
Yes.
Yeah. So this is a distribution feeder in Silkeborg. Silkeborg, actually I was born just around here. The red lines are 10 kilovolt lines, the blue lines are 0.4 kilovolt lines. So it's low and medium voltage. We've got some high voltage coming in and supplying the area. You've got the yellow boxes, which are cabinets, and they're connected to houses and apartment complexes. I'm just going to turn on the overhead imagery so we can start to see. It takes a few seconds to load the car identification. But what we can begin to, yeah, there we go. So now we can start to see where are cars now. We've also been working on, are they on a road? Are they in transit? Or are they just parked? There's some parked cars here. And now, what does this mean for the, if I just turn off the imagery again, what does it mean for loading of these cables? Because it's, the loading, it's a voltage drop, it could be a voltage increase. It gets a little bit complicated here, but what is the utilization of the infrastructure given these electric vehicles and solar and heat pumps? And here we have the lighter colors are at 100%. This is a flexibility scenario that I'm showing, and the darker colors are at 0%. So we can see here, this cable here, it's going to be fully loaded in 2035. And then we only have two options. We can either activate flexibility or we can go and dig up the road and put a new cable down. And there needs to be a cost-benefit analysis. Basically, you need to do it at a large scale. We also have these transformer points, which are the central distribution points that the cables connect to. And there we also see that some investment is needed. But generally, it's what we're seeing is the low and medium voltage will need will require significant investment and activation of flexibility to incorporate these electric vehicles in a socioeconomic optimal way. I can just take another example. Something else we've been looking at quite a lot is some of the fringe cases, including fast charging at petrol stations, which somebody pointed out to me the other day. I shouldn't be calling them gas stations. They should just be called charging stations in the future. So this is quite interesting. I'll just put on the orthophoto again. So this is actually a petrol station in Jutland, and there are two transformers supplying this area. We've modeled this area with 8 350 kilowatt chargers, the really fast ones that you just need a few minutes to charge your car in the future. 8 in each direction, north and south. And there we can see that there is no way getting around upgrading these transformers. You're going to have to upgrade them. The cables are okay though. So the cables, they have enough capacity, but the transformers don't. So it's really a dynamic system that we need to optimize. Something else we've seen is looking at batteries. Can batteries be used instead of these transformers here? Because isn't that the future? Well, actually, our models suggest that they won't be. The batteries are not a cost-effective alternative for this kind of case. Although batteries do make sense to invest in, but typically to trade on the energy markets in the future. One of the inputs to this model is future energy prices from the Danish Energy outlook. They do a forecast once a year, and there you can see over the next 15, 20 years, there's going to be huge opportunities as we integrate wind, as we integrate solar. Big changes in price that mean storage is required. It's really just a signal for storage. Okay, so that was my little demo. I think it went okay. And then I'll just round up what comes out of this. Well, you get, sorry for the Danish here, but you get an investment profile. And what we could see, especially probably in the 2030s, that there's going to be quite a lot of additional investment. From a percentage perspective, there's a lot more investment required in town areas than sort of city areas rather than more rural areas. But most of Denmark is rural, and most of the costs will continue to lie there. But percentage-wise, these things are shifting towards the town. Okay, I hope I came on just in time there.
You are exactly on time. It's quite impressive with the presentations. Well, a question for you, Emil. How difficult or easy is it for a small company like you to get into this business that with the large energy companies and so forth?
I mean, it's that's an interesting question. It's you can say in a way it's beneficial in Denmark because there are so many small utilities, and you just need a few visionaries to take the chance on something new. Most won't take the chance, and because it's a risk taking a small company, working with a small company. It's also not what they're historically good at. They're good at digging holes, and they're not. They don't think in terms of data-driven concepts. On the other hand, what we have seen in Europe is that most European utilities have big innovation centers and innovation funds, so they're constantly kicking off proof of concepts, and we don't have the same concept here in Denmark because the utilities are too small. So it's I think it's as good an area as any to get into, also because it's so interesting, and that's half the battle. It means that it's non-stop, but they're certainly challenging from. It's a totally weird area because these are natural monopolies. They have no competitors. What is driving their change isn't what drives change in most of the rest of the world. So it's you need to learn a few tricks.
And the opportunities for you to get into the European market, how's that?
It's it's okay. We get some offers to do proof of concepts. I think it's easier to reach out to Norway and Sweden, where it's more similar to Denmark. You have a couple of really large European utilities. Enel is one of them. There, it's a bit hit or miss. We've not succeeded with the really big ones yet, but I'm patient. We just need to keep on developing, and at some point it will happen, I think.
Yes, and collaborate with both the Danish sector and the universities. That could maybe also get an angle to that.
Yeah, so we've written some research applications. Well, I should say from that perspective, we keep on being invited from my. I did my PhD out at DTU. We get some great invitations to join some of these research projects. It's important that we only do the ones that are completely relevant for us, so we don't get sidetracked. And from that perspective, yeah, there's lots of soft money, and it's because I think I get the call because there aren't that many people taking a chance and trying to do what we're doing. But maybe that will change as the business opportunities they come over the next years in this area.
Yes. Thank you very much.